Hi guys, welcome to Learn Electronics Repair. I apologise for my voice today. I have something of a cold. Hopefully it won't last very long, but you know, electronics is a lot of fun, yeah? So even though I don't feel up to much, I'm still going to do a bit of work, okay? So this is the P4 motherboard we had on one of the Corroded videos, the retro computing videos, and this one had a lot of corrosion on it, so it was really the right mess. It had, I think it was bird excrement on it. You guys can probably see because I will refer back and link to the video from this one. We have a smashed inductor coil there, this one hanging at the board. We have a lot of capacitors smashed off. The plastic surround for the heatsink supporters smashed off, and I think the heatsink has been effectively flying around inside this case. I also noted later there's some damage in here as well, which I'm guessing is where the heatsink has hit. So that's the condition of the board. The three main problems are the capacitors, the inductors, and the corrosion. Now, the corrosion in particular is bad inside these slots, and I'm just going to show you actually. In particular, this bottom slot at this end here, I think without the light shining in, you can see there's a lot of corrosion on the pins there. And the one above also has some corroded pins, not as bad, but there's corrosion down the side of here as well. And there's some corrosion over here still. Yeah, in this area, you can see these terminators down here are bad and around this area. So how are we going to see if we can fix this? Well, first of all, let's just say we're going to try to fix this for fun. Yeah, just for the fun of it. And hopefully to learn some techniques on working on corroded PCBs like this. I have no idea if this thing is recoverable, okay? Well, we can try. So the first thing I'm going to look at is the easy stuff, and that is the capacitors and inductors, yeah? The capacitors, hopefully, these are all on the same voltage rail in parallel, and we have one here that is still in place, and we have another one over here that's still in place. So if the broken ones are in parallel with the existing one, we can use that to work out what the correct rating is for these capacitors, yeah? So let's have a look. So I have the meter on continuity mode. It's bleeping, okay? Let's have a look at these. Well, I think this is the one that's still there and the rest are broken off. So are these all in parallel? Let's have a look. So we'll go from this end first, and it should go, if they're in parallel, yes, to this end. So that's the second one. Let's go to this one, third one, so those points are all connected together. They could be ground, so let's look at the other end. So from here to the second one is there, third one is there, fourth one is there. So those are all in parallel, and that would mean really that they're all going to be the same value. So that's those ones. So we should easily be able to work out the value for these three. We have a few more over here. Some of these probably were never fitted anyway. These look like they were never fitted. That one clearly was fitted, and there's one here that was clearly fitted because parts of the leg are still in the hole, okay? So looking at this now a little bit more closely, that obviously had a capacitor in there. I'm fairly sure this one didn't. This one didn't, and this one did, okay? These may be in parallel with this one. Let's have a look. So first of all, are these all in parallel with each other? Okay, this one. No, that doesn't go to there. Does this one go to these ones? Yes. So that's another one. Yep. That's in parallel with all of these. So this one and these ones are all together. Now we have the other broken one. So there's this one. doesn't go to there. That end's connected together, but this is probably ground. Yes. So the white is the positive end, we also know that. Those two are connected together. This one isn't. Is this one part of these? I don't think it was. No, in fact it isn't. Okay, so we have possibly two banks of capacitors here. Let's see if either of them go to this one, okay? So this is where the capacitor is, the one that's still present. Okay. Goes to that one. Yeah, those two are connected to each other. Yeah, so that's this one and this one. They connect to each other. Okay, and we have the other one down here. Notice this is broken as well, so that's something else we can restore on this if we get that far. Okay, I'm just wondering, guys, if this one is also connected to here. Yes, it is. So we've now found another one. These two didn't have them in. So this one is in parallel with this one, and all the other ones are in parallel with this one. So what value are they? Well, this one is a 6.3 volt 3300. So we know what all those other ones are. Is this one the 16 volt ones? Yes, this is 16 volt 1200. So we know what value those two were. So that's those pretty much sorted out. I've just noticed while we're doing this that we have some more capacitors down here that look a bit maybe actually just dirty rather than anything else. This one feels all rough, kind of like knobbly. That may be a bad one, but again, they're present, so finding what those capacitors are is not going to be a problem. Okay, so for now I think we can say we've sorted out the capacitors. We know what we have if we decide to fit new ones. Next then is these three inductors. So these are three phases of the VRM. Are there any more phases? Well, you can see here we have 1 FET and 2. Let's have a look at this one. Well, we have maybe 2. So I can see in actual fact 1, 2, 3, 4, 6 FETs, okay? 6 MOSFETs. So it looks like, in fact, we have one high side and one low side. We can figure this out because if we measure from one end of the coil, it doesn't matter which end because effectively to the meter this is a short circuit. Put the meter where we can see it. So from one end of the coil, you'd expect us to go to the drain of one of them and the source of another one. Not that one. That one, drain source, goes to this coil. Look at the next one. Okay. We've counted for those two, these two. Not there. Drain of this one, source of this one. Yeah, that's the other phase, and then this will be the last one. So this will go to source of this one, drain of this one. The other drains will go to 12 volts and the other sources will go to 0 volts. So that's all basically there, but we need to figure out what value these are. Now, we may be able to do it with an inductance meter, although I don't have a dedicated inductance meter. We may be able to do it with a component tester, and we'll try that to see if it will work, but often they will not read low value inductors properly. But the other way we can do it is with an ESR meter. So I'll show you how to do that. We'll try the various methods. First of all then, we need to remove these inductors. These shouldn't be too difficult to desolder, but they might get quite hot. Yeah. This one, we can see one pin is out anyway. So I'm actually going to take this one off. They will all read the same. This one clearly needs to be replaced because the former is smashed, and that toroidal former, if you like, is made of ferrite or a similar magnetic type material, and it needs to be intact. Otherwise, the inductors will be gone. In fact, we can measure both if we can take them out, and we'll see the difference, okay? So let's see if we can get this one out and this one. I may do the third one as well. These are likely to get pretty damn hot, pretty damn fast, so I'm going to use gloves like these, yeah. Not asbestos gloves, but that sort of thing, okay? Heat resistance gloves. I do remember having asbestos gloves. I don't know if we can still get them. We'll add some fresh solder. If it doesn't want to go, I'll add some flux, and if it still doesn't want to go, I'll just warm the area with hot air. Okay, there's some flux, that may well help. In fact, it did, but it still took some effort to get enough heat into this. Okay, let's see if we can remove this. Yeah, it's loose, so warm one end. And just push the inductor over. Yeah, it came out the board, in fact. Warm this end, push it the other way. Still a little bit tight on that one. Go here again. I think it's come out now. This side, just got plenty of heat into it. And there it is, okay? So these did the job. Let's do the other ones. So this one is going to be fairly simple because it's already come out at one end anyway. Well, it actually just fell out the board, that one. And the last one, the broken one. And it's out. Okay, so there are our inductors. We'll test those in a very short time, but let's try and do something with this corroded board as well, because this is going to take a while. Once we put some solvent on there, if you like, or something to remove the corrosion, we have to leave it a while, okay? With the corrosion, we also have quite a mess inside the AGP slot as well. If you look down there, that's quite corroded in that area, so that's another problem we have. So we need something that will effectively remove the corrosion. One of the subscribers commented on the video where I featured this board, goes by the way of Man at Arms, and he suggested a method to remove the corrosion, particularly in these slots. Also, another subscriber, Good Thor, made a suggestion. So Good Thor's suggestion was the only way we could clean this up was using an ultrasonic cleaner. Now, I've actually been offered an ultrasonic cleaner to review on the channel, but it was too small for things like these motherboards, so I declined to accept it. If somebody offers me or would like to send me an ultrasonic cleaner, a bigger one, I will certainly feature it on the channel. But it's also quite possible, according to Thor out there, to actually build one. So that could be an interesting project, and we could try that if this doesn't work, or maybe try it anyway. It's an interesting project, okay? But for now, we will go with what Man at Arms said. And he said basically to soak some kitchen roll in vinegar and stick it in the slots. And because the kitchen towel or kitchen roll was soaked in vinegar, it will keep the acid in contact with the connection here for longer, so we can leave it for a couple of hours and then wash it with soap and water. So of course I needed some vinegar, and I asked the wife, hey Julie, you'll have some vinegar, you use that in cooking, yeah? So she said, well, what do you want it for? So I told her what I wanted the vinegar for. She said, oh, use Coca-Cola. I said, well, yes, but that's not like, tastes like vinegar, does it? She says, no, but says on some of like the cooking and kitchen type girly channels what she watches, because she is a girly, so there you go. On the girly channel, she says they use that for cleaning ovens and such like. So what I'm going to do in this video is to use vinegar and also to use Coca-Cola, and we can compare the results. Now it just turns out this morning I've had a bit of a cold, I wasn't firing on all 4 cylinders, and I forgot to bring the vinegar with me. So I went to the local supermarket and I was looking around trying to find it, and who should I bump into but Mrs. Ollie. Ollie being the guy who runs the German gaming channel for pensioners here, okay? Rentner Zocht, which means basically pensioner games, I think. So I bumped into Mrs. Ollie, or Elga is his name, and I said, I can't find the vinegar. She said, oh yeah, and she showed me where it was, and I explained what I wanted it for. She said, well, if you want it for that, don't use the normal vinegar, use this stuff. So I'll show you what she got me to buy. And because of this, I now have 3 different things we can try, okay? So one is standard Coca-Cola, the sugary stuff, not this zero one, which I always drink, but the full fat Coca-Cola. So I bought a can to try it. Some people may say that's a waste of a can of Coca-Cola. Some people like me will say, well, you shouldn't be drinking stuff with that much sugar in anyway. So there we go. I bought a bottle of vinegar. So this is Spar, the local supermarket. Vinegre, there we say. Vinegre, I can't do Spanish for the cold. Okay, it's white wine vinegar, okay? So we're going to try that. And Helga said to try this one. Essig Essence. So this is concentrated vinegar, basically. It says on here 28% acid, I believe. Okay, so this is concentrated vinegar. So we're going to use that one. We're going to use a normal vinegar, which it doesn't actually specifically say what the concentration is. So we're going to try that, and we're going to use Coca-Cola. The first suggestion then, man-at-arms, use kitchen roll. He didn't say to wet the kitchen roll first, to stick it in first, or how to do it. So I'm actually going to try and get the kitchen roll into the slot first. I'll try using enough to effectively fill the slot if I can. If it won't do this, I'll try wetting it first. Okay. Well, it doesn't seem to want to stick in very well. So let me try wetting it with vinegar first and then sticking it in there. Okay. Let's see. So this is the regular vinegar. Now, according to my wife, Julie, white vinegar is best, and it's not that it's more acidic, but that it effectively has less impurities in and doesn't smell so strong. That certainly smells of vinegar. But I'm going to use this. It's what I could find at the supermarket. So let's see if we can get it into the slot. Not easily. Okay. I will find a technique that works. I'll go back to the original idea. We'll stick the thing in first if we can. Okay. I seem to be having a bit more success now. Okay, we'll go with that. Well, I've got it on the PCB and everywhere. I've made a mess. Let's clean that up a little bit. But I certainly have plenty of vinegar in the slot, okay? I'll just roll up the kitchen roll, soak it up in the vinegar. Okay, that's that one. Now let's try the other one with the concentrated vinegar. Okay, I'll try and keep this scientific, and I'll try to keep the cross-contamination as little as I can between the two. This is going to be very difficult to pour. Okay, I've put a little bit into a small bottle. Okay. Again, I'll try and stick this as much as I can into the slot. Okay, and there we have it. While we're doing this, let's just have a look at this area here where it's a lot of corrosion. So I'm going to try the same thing. I'll just take this jumper off here. I'm going to soak a bit of cloth in here and just press it against the board and leave it pressed against it. So this is the concentrated vinegar, okay? So we'll just press this against the board in this area. Okay, a bit more. Okay, we'll try that. Let's look at this AGP slot. So we'll use the same technique, but this time with Coca-Cola. Okay. Copyright branded Coca-Cola, okay. It's actually easier to get this in the AGP slot than it wasn't the RAM slot. A little bit wider. Okay, definitely going in there. Looks good. So, colour it is. Yeah, the genuine stuff, not any other sort. Okay, again, I'll put a little bit into a bottle or something. Maybe slightly contaminated with the vinegar, but I can't see any better way to do it. Okay, there we go. The last thing we will try is just down in this area where it looks corroded. Let's put some more colour here as well. Okay. There we go. Okay guys, so let's leave that for an hour and a half, something like that, and then let's have a look. While we're waiting for that to do its work, let's look at these inductors. So this is a El Cheapo component tester, basically. The ones are about €6 or €7 or so. Let's see if we can measure these inductors. So I'll hold this against the socket, otherwise I'll have to use some clips. And it just says it's a resistor, and that's the problem with these things. They will not test low value inductors. They just think they're resistors, okay? Try another one. Yeah. And the last one, the one that got smashed. Okay. And it doesn't really see any difference between them. It tells us nothing useful at all. And these are supposed to test inductors, yeah? Well, guys, comments below. Let's try this. I reviewed this recently. This is the little DSO TC3. This is also a component tester. I've not tried this on these sort of inductors. Interested to see how well it works. When I reviewed this, I very much liked it. So let's see what this thinks of it. So I'll attach these little leads. It just makes it easier. Okay. We'll switch this on. Okay. And let's see. So this is one of the good ones. Connected to our inductor. What's it think? So we want to go M tester. Okay. Unknown or damaged part. That's okay. Well, that measures it, okay? It's 0.01 millihenries, okay? Which is effectively 10 microhenries. So this does test them. Look at this one. Okay. Reads the same. And let's look at the bad one. Okay. And that actually reads the same. That's interesting, isn't it? And now with the ESR meters. So this will not actually give you the reading in millihenries, but you can work it out very easily. So first of all, we want to zero this. Okay, hit 0. Okay, now let's measure one of these. So this is one of the good ones. And that reads 1.27, okay, ohms. Let's look at the other ones. .33. So we can say the average is 1.3. How about this broken one? 0.1, so a big difference, okay? So we had 1.3 or 0.1. Just be sure again, one of these again. Yeah, 1.3. Okay. To work out the inductance in microhenries from the resistance on the ESR meter, there's a very simple formula. I made a video about this. I will link it so you can understand why if you want to. Or you can just use the formula and not worry about the why because it works, okay? So the formula is to take the resistance and divide it by 0.628, okay? So our two intact ones, the average was 1.3. We had a 1.27 and a 1.33. So 1.3 was the average resistance we had, and we divide that by 0.628. And this will tell us the inductors are microhenries, and it's 2 microhenries. You see, the reading is completely different from what that component tester was telling us, even the one that worked. The other thing it told us, and the other one didn't, is this bad one is bad. So with this one, it was reading 0.13, I think it was. 0.13 divided by 0.628. Yeah. And it's 0.2 of a microhenry. That's what you'd expect because that is a bad inductor. We also know that the good ones are about 20 microhenries, which actually is a very reasonable value to expect. So you can see that the ESR meter gives us a far more accurate reading and a far more useful reading than the component analyzer. Short of buying a dedicated inductance meter, guys, that's the best way I know of testing inductors and measuring inductors. This always works, by the way, as long as you use a 100 kilohertz ESR meter. Any real ESR meter would be 100 kilohertz. It's pretty much a standard. But if you find some cheap device that is not 100 kilohertz, it's not going to work. So buy yourself a 100 kilohertz ESR meter, or work out what the constant is yourself. It's not going to be 0.628. Okay, so we can now look for some inductors as well, and that will fix our board. We can find some scrap ones that will look like these, and we can test them and we can measure them, yeah. We could even, if we have to, take the windings off this one and put them onto another former. That may also work, but we have a plan, okay? Now let's wait for our acid and vinegar and Coca-Cola to clean the board and see if it worked. And here are the results, guys, so let's have a look. It might not be quite dry yet, I've just washed it in water again. So this RAM slot nearest to the bottom of the screen, this had the strong vinegar in, the concentrated vinegar, okay? And that actually looks quite a bit better. The green deposit seems to have gone out of here. Okay, there may be a little bit of corrosion still in there. I think I'll give it another go, but that is a definite improvement. Let's look at the other ones, so the one towards the top of the screen. This was the standard vinegar, white wine vinegar. That also looks considerably better. I would say, to be honest, there isn't a lot of difference between the performance of the two, but both seem to have helped a lot. Okay, this area was cleaned with Coca-Cola. Still a little bit wet, but we can see it. Try and just get rid of the glare. That does seem to have helped. Okay, so this area was cleaned with the vinegar again, the strong one. That is much better. Okay, that area is much better. Again, I'd like to give it another go, but definitely improved. And we'll look at the AGP slot. Okay, so this had the Coca-Cola. Board still wet, as I did say it was. That also looks much better. So from this quick experiment, I have to say that Coca-Cola, vinegar and concentrated vinegar all helped. It looks much better. Okay, so what I think I'll do with this one, we can definitely consider having a part 2. I think I'll just soak some more kitchen roll in vinegar and just effectively just spread it across the board. We can see a little bit of corrosion down in this area. Okay, by that RN7 for example. So that's what I'll do. I'll effectively just soak kitchen roll in some more vinegar, give it another go. And then we'll see if we can find some suitable inductors off another scrap board. We know what the value is. That's a good start with that one. Looking at the area where we just put some vinegar on the kitchen roll, so that was this area. This was the strong vinegar. I don't think I put any around the Mozart chip, so that probably wants some more. It's still corroded there and in that area, but down towards the front is a lot better, so I'll do the same on that area. And the other area where we tried the cola, which is here, well, it has cleaned it up somewhat, but I'm not sure in this instance it did such a good job as the vinegar did. So once again, we'll wad some kitchen roll in this area and use vinegar. Okay guys, I hope you enjoyed that one. Get into the comments below, let us know what you think, anything else you'd like us to try on this board. And I look forward to seeing you all on another Learning Electronics Repair video very soon. Ciao for now guys.